Section 3.1 Maximum and Minimum Values. Definition. Let C be a number in the domain D of a function f, then f of C is the absolute maximum value of f on D if f of C greater than or equal to f of x for all x in D. Absolute minimum value of f on D if f of C less than or equal f of x for all x in D. So you understand the absolute maximum and the absolute minimum is that the absolute maximum is the point, is the highest point. When we're talking about the height, this is talking about the y. So if you can see the y is the height. So this is the height. Then from the first graph, you can see that this point is the highest point. So this point is the absolute maximum. And this point, look at the height, this is the lowest point, so absolute minimum. The second graph, so we have this point is the absolute max, and this point is the absolute min. So understand that if you are at absolute max point, you are the highest. And if you are at the absolute min point, you are the lowest compared with the other points in the graph. Number 2, definition. The number f of C is a local maximum value of f if f of C greater than f of x when x is near C. The local minimum value of f if f of C less than or equal to f of x when x is near C. You look at the definition number 1 and definition number 2, they look very similar. So what is the difference between the local maximum and local minimum compared with absolute maximum, absolute minimum? Local maximum, you can understand this is the location where it's on the top of the mountain. So we need to have the mountain. So we need to have something like this. And the local minimum is like in the valley. Okay, so we need to have mountain or valley to get the local max or local min. So go back to the graph above. So we have this is the mountain right here. You see this? Okay, so at this point right here will be local max because we have the top of the mountain. And this point right here at x equal to 3, this is also local max. And we have 2 points in the bottom right here and right here. This is local min and local min. So only when we have like a valley. So if you notice this point is both absolute max and is also local max. Now we looking for the local max for the second graph. So we only have one local max because we have like a mountain right here, right? Okay. And then for the local min, we have 2 point local min. So we have this and this. So this is local min. And this is local min. So you look at this point, you can see that this point is both local min and absolute min. Example number 1 below, we have f of x equal cosine of x. So you see the function cosine is the periodic function. So we look at those points and so on. So you can see that those points are the highest point, right? So they are the absolute max. It's also absolute max because if you add here, the other point is lower than us. Okay. And also this is like a mountain also. Okay, so those point is also local max and local max. In the bottom we have those point, and if we're at those point, we are having the smallest value, which is -1. So this is the absolute mean, and it's also we have like a valley also. So this is local mean, absolute mean, and local mean. So how do we write down? So the absolute mean and the local mean happen at x equal pi, and then 3 pi, and then continuous 5 pi, and it can be negative, right? Negative pi, negative 3 pi, and so on. So 1, 3, 5, and so on. It is the odd number. So you can write it like this. So n equal, so we use in math, we use 2n to represent for even for any value of n, because when you put in n value, 2 times that value will give even number. And then for odd, we will use 2n plus 1 for odd value. So x will be 2n plus 1 pi. And for the absolute max and local max, so x will be is happen at the even number, like 0, like 2 pi, like 4 pi, and so on. So they are even 2 pi, 4 pi, and so on. So we will use x equal n to n represent for the even for any value of n, and then pi. Example number 2, we see this point. This point is the lowest point. So this point, f of 0 equal to 0, is an absolute mean, and it's also a local mean. We don't have the absolute max. The reason why is that when you look at these 2 points just keep extend more and more. So it's never end. So we don't have absolute max. Okay, so no absolute max. No absolute max. Example number 3. When we have this side, it just keep going on forever. It's no stop. So same reason, no absolute max. Okay, no absolute max. And similarly, this point is never stop. So we have no absolute mean. And this problem, we don't have local max, local mean. So because we don't have like this or like this, like valley or mountain. Example number 4, let's looking for the maximum, the absolute max. So this point is -1,37 is absolute max, because this is the highest point. It's give 37 the height, right? The highest. And this point in the bottom, 3,-7 is the absolute mean. Now we're looking for the mountain. So local max, mountain give local max. So this is local max, 1,5. And we have 2 local mean valley. So we have right here local mean, and right here we have local mean. So the point 3, -27 is absolute mean and local mean both.